In this video, we're going to go over how the projection formula is derived. So a projection is basically when you shine a light down from one vector onto another. So if I have the vector v here, the vector u here, and I want to find the projection of, let's say this is vector v, I want to find the projection of v onto u. That just means that we shine a light down from v, and we want to find the resulting vector, which is going to be this vector right here. This is proj v onto u. To find this vector, we first have to figure out a structure to find it. We have to agree that, first of all, we need to find a unit vector in the direction of u, and then we have to multiply that by the length of the projection, which is equal to the x part, or the horizontal part of v. So let's find the unit vector first of u. To do that, we need the length of u. We have to take the reciprocal of that, and we have to multiply that by u. Okay, so this is the unit vector in the direction of the projection that we want. So now we need to calculate what the length of this is actually going to be. And to do that, we'll set this angle equal to theta. And using simple trigonometry, we have that the length of what we want, let's call it L, is going to be equal to the length of V sine of theta. No, the length of V cosine of theta. And this is just from SOHCAHTOA. Cosine theta is equal to adjacent over hypotenuse. So adjacent is going to be equal to hypotenuse times the cosine of theta. So now let's multiply them together. We have 1 over the length of u times u times the length of v cosine of theta. Now let's multiply by the length of u on both on the top and the bottom. So we have the length of u over the length of u times 1 over the length of u times, I'm just going to rewrite the order here, the length of v cosine theta times u. Now the reason we did that was because we see from this term that it's very close to the dot product formula. U dot v is equal to the length of u times the length of v cosine of theta. So we're timesing the length of u just to make it simpler, so we can use dot products to express it instead of this big ugly thing. So now we'll see that we can transition into the length of u times the length of v cosine theta over the length of u times the length of u, all times u. Now the top is just going to be u dot v. That's just from the dot product formula. And the bottom is going to be u dot u. And that's again from the length formula and the dot product formula. The dot product of u and itself multiplies each element of u and itself, of u by itself, right? So it basically squares each element. And that's the same thing as when you take, for example, we have u equals the vector u1, u2, u3, for example. Then the length of u is going to equal the square root of u1 squared plus u2 squared plus u3 squared. And then when you multiply that by itself, the square root gets taken out, and you're left with just this inside section here, u1 squared plus u2 squared plus u3 squared. And that's the exact same thing as the dot product of u and itself. And then finally we have multiplied by u from here. And we're done.